what happened in 1944?
World War II.
Nice, mates. I think 44, isn't it? 45. 45?
39 to 44.
39 to 44, yeah. We'll have to check. We'll have to check. It's 45. I reckon 44.
It was 45.
Ah, it's cheating. Prove the teacher wrong. Alright, let's scroll up the top here. Okay, so I'm just talking about how we can use our calculator, right? So I'll open it up. And remember, I've got the old one, so it's a bit clunky, but let's get straight into it. So we've got our first question here. State the x-intercepts of this quadratic. So ideally we're applying the null factor law, but what we can do is graph it and g-solve the x-intercepts, right? So I'm going to go into my graph mode. I'm going to type in the equation I've got there. So 3, your x plus 1, and x take 2. Graph it. All right, can't quite see the whole quadratic, so we need to change our V window. All right, now you can just go V window standard, but if I'm looking at it, okay, this is how you should be starting to think about it, is I can't see the bottom of it. All right, I can see the 2 lines, but I can't see the bottom of it. So I need to change my Y minimum. I need to make it larger so that I can see more down. So that's my Y min, right? I need to change it down. And I've always said the safe rule of thumb is just to set it to standard. Set your V window to standard, okay? F3 and then F3 again, and it's producing that graph. The other thing to say is in the test as well, where you're required to graph, I've given you a Cartesian plane, all right? And that's useful for you because it means you know what V window you've got to put in. Let's say you're confronted with the question, it says, yeah, graph the equation, and here they've got minus 10, and here they've got positive 20, and then down here they've got negative 50, and up here they've got positive 20. Well, you've got your x min, x max, y min, y max. Match it to the Cartesian plane so that your graph is going to fit perfectly on the Cartesian plane presented for you. Okay, so all we've done, look, I've graphed it, and we want the x-intercepts. X-intercepts, roots, zeros, solutions, they correspond with the factors. We go g-solve, root, okay? So my first one is x is minus 1. And my second one, I press the across arrow to get to it, x is 2. All right, so that's the first part. For the second part, determine the y-intercept. All right, so y-intercept occurs when x is 0. We can just g-solve, F4, y-intercept. All right, so we've got 2 marks there just from g-solving those things on our calculator, right? The y-intercept, not the x value, don't write the x value down. Y-intercept, obviously, it's the y value, then x is 0. All right, so you can perform all of those manually, all right, or you can get them from your calculator. State the equation of the axis of symmetry. So this is a good point for me to clarify for you. There's 3 ways really. There's minus b on top of 2a. There is p plus q on top of 2, where p and q are the roots. Or it's the x coordinate of the vertex. All right, so if we're looking at the graph, the x-coordinate of the vertex is the minimum. All right, it's a minimum because it's opening upwards. So if I g-solve that minimum point, look, see how it says x is half? What's the equation of the axis of symmetry of the vertex? X is half. All right? Cool. Now, given a equals 3, state the effect this has on the quadratic. This is deliberately ambiguous, all right? There's a couple of things that you can answer. I think the most, like you can talk about the dilation and so forth, although that's not part of this test. I think the important thing to say is A is positive, all right? 3 is a positive number, which means it's going to open upwards, all right? Remember, if we have a negative number, it's going to open downwards. So we're going to accept, like, when you've got, you know, talk about what it means, there's multiple answers there. So just selecting one of them. Okay, find the equation of the graphs. Unfortunately, they're a little bit harder to reverse engineer. One thing you can do though, is once you've got your answer, you can graph it and check if it corresponds with the same one by tracing along it. All right, so hopefully you see here where my mouse is at the moment, trace, that's one of the functions. We can trace along, we can put in any x value. When x is 0, what's the y value? When x is 2, what's the y value? And it tells you those coordinates. And if the same coordinates correspond with the function you're presented with, it's the same graph. So that's one way you can check your answer here, but it's not a way that you can get your answer as such. Okay, we'll move on to this one. Factorize the quadratic by completing the square. Okay, so the quadratic we've got is x squared, take 4x plus 3. Alright, so I'm changing the graph I've got there. I've graphed it. Factorize the quadratic by completing the square. Okay, let's pretend I don't know how to do that. I can't remember how to complete the square. Oh no, I'm stuck for this question. I'll just move on. That's not the case. Alright, look at part B. Hence, state the coordinates of the vertex. I can get that from the graph. It doesn't matter if I've answered part A or not. I can go back and go, what's the coordinates of the vertex? Well, again, it's a minimum. So I'm G-solving a minimum. G-solve the min, and you list them as a set of coordinates, right? X is 2, Y is 1. We've G-solved those coordinates. Right. 2 and, thank you, Charles. All right, 2 and minus 1. Now, this can actually help you answer part A. Part A says write it in completed square form. Remember, this is HK. They're the coordinates of the vertex. So if this is the completed square form, x take h squared plus k, and you've got h and you've got k, you can go from there to here. All right? That's the answer, okay? And you know this a value, you know that a value is going to be 1, because if you look at the original function, the coefficient of x squared is 1. All right, so you can G-solve that vertex and reverse engineer your answer to part A. All right, you won't get full marks, but there's potential to get a mark there. All right, so we've answered part B. We can go back and check our answer to part A, right? Find the axes intercepts. Okay, so this means the x-intercepts and the y-intercepts. All right, well that means I'm G-solving the roots. I need the roots. All right, so I've got 1 and 3, and I'm G-solving the y-intercept. It says axis intercepts, so it's deliberately vague. It wants all 3. It intercepts the x-axis here and here, and it intercepts the y-axis at y is 3. All right, so you need to answer all of that. And then to graph it, all right, well, all you're doing is copying this image over. All right, trace along it if it helps. I've said in the test, we're providing you with Cartesian planes where they're needed. All right, moving on to this one. Fully factorize the cubic and draw its graph. Okay, so I'm gonna pretend, let's pretend we didn't know how to factorize the cubic. That's okay, we can still get marks for the graph. X to the 3 plus 4x squared take 11x take 30. Let's graph that. All right, x to the power of 3 plus 4x squared. Does it take 11x? Take 30. All right. Can't see it properly. Okay. What do you do when you can't see it properly? We need to change our V window. So you can see I can't quite see the peak, and I definitely can't see the trough. So one thing you can do is you can just zoom out massive. I don't need to change x because I can see all the x values, but I need to change y. So you can just change that to minus 100 and 100. I'm going to change it to minus 20 and positive, other way around, minus 50 and positive 20. All right, and you just keep zooming out until you can see that cubic shape, right? Okay, so that can help you to get the marks for drawing the graph. But let's backtrack again. Fully factorize the cubic. All right, so we've got x to the 3 take 4x squared, plus 4x squared, take 11x, take 30. And we're told it's equal to x plus 5, and we have to find out the quadratic factor, right? Ax squared plus bx plus c. And then let's pretend we can't do that, right? We don't know how to do that. That's okay, because we can get the roots from here. If I g solve the roots, all right, there's my minus 5, okay? X plus 5 and my minus 5. I've got x plus 5. What's my other root? I've got minus 2, so we're going to have x plus 2. And I've got x take 3. So you can still fully factorise the cubic from the graph. Okay, you can express it in fully factorised form. Not that you get all the marks for it, but there's still a way of getting some marks or even checking your answer. Okay, on to question 5. Now, with this kind of question, we are looking for the process, but nonetheless, let's show you how you can check your answers. So you go to main menu, and we go to the equation solver. It's a polynomial, so we press F2, and quadratics, okay? So the degree is 2. Now in the first one here, we have 4x squared take 8x equals 0. So we're going to have 4, 8, and there is no number. The constant term, the value of c is 0. Solve that quadratic, you get those solutions, okay? Same again with the next one. We've got x squared plus 5x takes 6. We've got a is 1, b is 5, c is minus 6. Okay, you need to take whether it's positive or negative with it, solve it. We've got the solutions, 1 and minus 6. And look, here you're asked to factorise it. Even if you can't see the factorisation, you can take the minus 6 and the 1 and reverse engineer it. Right, can't you? You can go from minus 6 is a root, therefore x plus 6 is a factor. 1 is a root, therefore x take 1 is a factor. And so you can get the marks that way. All right? You're basically cheating, right? Moving on to the next one. You absolutely must move the 2 over. So it becomes x squared take 3x plus 2, and then you put in your values of a, b, c. Everything needs to be on the left-hand side. The same with d. All right, quadratic formula. Even then, like if you put this in your calculator, it's going to pop up with it'll be the same value, they might represent it differently. So that's another way of checking it as well with a, b, and c. All right, we'll keep scrolling through there. Okay, let's check this one out. One way you can check your answer is to graph both of them. We've got x squared take 5x plus 7. So I'm going to go back to my graph mode now. X squared take 5x plus 7. And the line we found was 3x take 9. So we graph 3x take 9. And we can see the line is tangent to the curve. Okay? Even then, like one thing you could even do is experiment around with it. Like let's say you can't solve C, but you can just do some trial and error. Is it tangent if I do 8? Is it tangent if I do 7? All right? And then you're just G solving. How many points of intersection are there? Here there's 2 points of intersection, so it's not tangent. It's going to be tangent when? 1 point of intersection. All right, spending a bit too long. So let's go through question 9 together. Okay? All right, question 9 and 10, we'll go through together. So there was a little bit of an issue there. We said we need to restrict it to 3 pig pens in order for the question to maintain the equations we've got there. So we've got 3 pig pens like this. So this length is x, and this length is y. So we've got 6x plus 4y. Okay, part 1 says, explain why 6x plus 4y is equal to 600. And all we need to say is something like this. There are 6 lengths of x and 6 lengths of y, and together they add up to 600 meters of fencing. Hang on. 4y. Yeah, let's leave the answers out and we'll just go through the test. So I'll have it open. Formative test. I'll just refer to the question. Okay, 6x plus 4y is 600. So we want to isolate y by itself. So that's part A. There are 6 lots of x plus 4 lots of y that equals 600. Part B. Show that the area of each pen is given by this equation. Okay. So the area of each pen is equal to x times y. Right? The area is going to be equal to x times y. But there, we've got two variables and we need to express it in terms of one. We need to rearrange y to get x by itself, right? So I have 6x plus 4y equals 600. So we'll rearrange this to get it by itself. Divide both sides by 4. All right, which is 150, take 3 on 2x. 3 on 2 is the same as 1.5. We'll maintain consistency with the question. 1.5x. So what we've done there, we started with this expression. All right, we've rearranged it to get y by itself. And now we're going to take that because the area is equal to x times y. All right, so that means the area is equal to x times 150, take 1.5x. Okay, and then we'll distribute it. We have 150x, take 1.5x squared. All right, is that all okay? All right, so let's move on to the next part. Say, find the dimensions of each pen that provide the maximum area. All right, so here, you don't even have to use quadratic techniques. Remember how I've said we can use our calculator, right? You can graph this and g-solve the max. Let's do that. Okay, let's graph that equation and g-solve the max in order to answer it. So I'm going to calculate on the screen. So we've got, I'm graphing this equation, the area equation, right? 150x take 1.5x squared. Okay, I'm graphing that equation. All right, can't see it properly. Need to change my V window. Now, in the context of this problem, right, we're talking about x as a dimension, which means we're not interested in negative values of x. X can't be negative because we can't have a negative dimension. Y, we're just going to need to absolutely crank up massive. So let's set it to 1,000, see what it looks like. All right, we're starting to get there. I'm starting to see a parabolic shape, right? So I can see basically it's approaching this peak. I need to basically double or triple my x, and I need to maybe crank y up a bit more as well. So let's go back to V window. I'm going to crank x out to 30, and I'm going to crank my y max up to 5,000. All right, still not really close. I need to crank x out a fair bit more in order to see the quadratic. So go back to V window, x max, let's go 100. All right, nice. Okay, so just process of elimination until I can see the graph nicely. Now we're interested in when is the area maximized, because the dimensions are changing, right? They're varying, and so we're just going to g-solve the max. All right, g-solve the max. The max occurs when x is 50. All right, and what is this equation? This is the area equation. So on the x-axis, I have the value of x. On the y-axis, I have the area. And so we can see the area is maximized when x is 50, and the area it corresponds with is 3,750. So that helps you answer the next two parts, right? we've got x is 50. Alright, so for part C, we can just say x is 50. And when x is 50, alright, the area, so that's the answer for part D, I think. Let's go back to the question. State the maximum area. We need to fix these answers. Is 3750. Alright. Now just to answer part C, okay? Part C says state the dimensions. So dimensions mean, like the dimensions are x times y, aren't they? Now we've got x is 50, but we're saying what's this value of y such that the dimensions are, such that the area is 3750. What's this value of y? And you can get it from anywhere, right? We can get it from here. When x is 50, y is equal to this equation, so we can substitute 50 in here. 150 take 1.5 times 50, 75. Okay? And then we've satisfied this question, right? We've got 6 lots of x, okay? 6 lots of 50 is 300. 4 lots of 75 is 300. Add them all together, you've got 600. Here's the dimensions, 50 by 75. Okay, if it asks for dimensions, you need to state it as dimensions. If it asks for area, well, that should be meters squared. Okay, that's the area. But how do we use our calculator there? Even if you, there's going to be a question like this, right? Even if you can't get part A, part A, we want to get that, you're just making a statement. Part B is a little bit trickier. But part C, all you need to do is graph the area function and g-solve the max. All right, it doesn't require you to do it using the axis of symmetry form. G-solve the max, we saw on the calculator here, when x is 50, the area is 3750. So we've got the value of x for the dimensions, we've got the area, and then to get that other mark for the dimensions, we just needed the value of y. Okay. So sorry about these solutions. I need to fix them up. It's a broken question, so we'll get through. I'll get Mr. Virgo's done it on his iPad, so I'll get him to fix that for us. All right, we've got number 10. Does anyone want to talk about 10? If one person wants to go through it, I'll go through it. Yep, excellent. Let's go through number 10. So we've got an open box has an area of 80 centimetres cubed, and it's made with a tin plate with 3 centimetre squares cut out of its corners. So we have a net here, and this is straight out the textbook, this one. These lengths are 3. And the original, the volume is 80. All right, the volume is 80 centimetres cubed. So we're going to fold those sides up and make it into a box. Now, the thing that we need to do here is define x. So we've got, in this circumstance, it's made from a tin piece that's originally square. And so we let x be the original dimensions, right? X times x is the original dimensions. And so if this length is x, and this is 3, and this is 3, then this distance here is going to be x, take away 3, take away, it's x take 6. Okay? This distance has to be x take 6, because we're subtracting those 3 from each side. And the same with this one. If the original tin piece is a square, this is x, we're taking away 3 from the top, 3 from the bottom, we're left with x take 6. Then we say the volume of a 3-dimensional prism is equal to length times width times depth. All right, so if you fold up these edges, here's what we've got. We've got x takes 6, x takes 6, and then we've got this is 3. All right, you can see I'm folding that up, folding that up, folding up, welding it together or whatever. Okay, and so the volume then is x take 6 times x take 6 times 3. All right? And the volume is equal to 80. That's what we're told, the volume is 80. Okay, so then that's part A, show that. Part B, hence, find the value of x which satisfies the equation. All right, so for this one we will use our calculator. Now, there's two ways we can do it, right? One way does involve a bit of algebra, okay? So what if I was doing it, what I would be doing is expanding this. Take 80 equals 0. Expand this, collect like terms, and then put it in equation solver. Okay? That can be done. It does involve a few steps of expansion. The fastest way, all right, is going to be to move the 80 over, like we've done here. We've got this equation, and we want to know when it equals 0. We just graph this. It's not pretty. It is a quadratic. We can graph it. We don't need to put it in simplest terms. We can just type all this into our equation solver, into our graph mode, graph it, and g-solve the roots. Then you can just bypass all that expansion. You don't have to do it. So let's do that. All right. So I'm going to exit out. I'm going to show you how we type all that in. I'd go 3 bracket. I'll get rid of my top function too. 3 bracket x take 6 bracket, and you know, you can just write it out twice, or you can write it as squared. It doesn't matter. It doesn't make a difference. 3 times x take 6 squared. Take 80. Oh my gosh! Have a look at this. X take 6 is what? X take h. X take 6 squared. X take h plus k. All right, so you can start to see it's a completed square. It's a perfect square, vertex form. All right, so we've graphed that, and we're just interested in the roots. G-solve the roots. Has to be a positive value of x. Good. What's going on here? G-solve root 0.836 and 11.16. 0.83. I'm skeptical of that. Can't see it very clearly. I'm just going to change my V window and make it a bit bigger there too. Why are we getting 0.863? All right, so we've got two solutions. Okay. Why are we getting that one?
How many decimals do you go to test?
3 significant figures. Oh my gosh. It's a lot harder to use a calculator on a laptop. Minus 100. There we go. Yeah, no, that's right. Okay, so we've got the two solutions. We're going to have to reject one of them. Okay, so those are our two solutions, 0.863 or 11.16. And if we use the 0.83, what we've got x take away 6, right? And if you have 0.83 take away 6, you end up with like negative 5.1. So that can't be the case. So we're rejecting that solution. So then the correct solution is 11.16. Now the question in the test, it's a little bit like this one. But when you get your two answers, one of them's negative, one of them's positive. So you just reject the negative solution straight away. So it's a bit easier than that. Okay, and then for the last part, state the initial dimensions. Well, remember our initial dimensions of the tin plate were x by x. So our initial dimensions are 11.16 by 11.16. Okay? Alright, so any questions about that? Does anyone want me to perform the algebraic method, the expansion? If one person wants me to do it, I'll do it, but if we're happy, we can stop there. Alright, so hopefully, look, again, I'm always talking for longer than I want to. Hopefully, you're feeling sort of more comfortable with your calculator. How can I use my calculator to not only help me get answers, but also to check my answers? It's a very useful tool. Make sure we use it. Alright, any questions? Anything else left to do? Very good. Alright, so let's see how we use our time today.